Okay, now basic circuit we covered. We developed a diode circuit, we developed a SCR circuit, then we go beyond this and we make several bridge circuits. And before this exercise, as you knew that we completed one small circuit, HVDC circuit of around 300 kilometer of at 250 kV. As I told you earlier that below 200 kV AC is economical as compared to the DC, because the complete cost of DC is raised up due to these electronic circuitry, this DC circuitry, converter and inverter, these rectifier substation and in converter substation. Now what I need to do, I want to integrate this HVDC line output, which is obviously the AC, and I want to integrate this into the existing circuit of, let's suppose this is my national grid and I am generating here at 345 kV and I want to integrate. So first of all I I developed this breaker and inserted this breaker in between these two connection points, and I want to make it idle initially, so I just keep it open. My total observation time is 0.5 second, so I want to make a first operation after 0.5 second, means at 0.6 second. Okay, now means that during this simulation which I am going to perform now, my breaker will remain idle and will remain open, and I have the output on the both side without any integration. And after that I will, after this simulation, after that I will put it on. Okay, now let's see what will happen and how this will affect the system. Now these are my outputs. I have voltage here, very low voltage. These are per unit values as I told you earlier, and these are my currents. You can see from the virtual wire option which I told you earlier, these my bus voltages and my control circuit. Okay, now I make a control circuit on 230 kV because receiving side of this substation is 230 kV. Yes, 230 kV. Now what I will do, I will put on my this breaker at 0.2 second, and let's see what will happen. Especially I want to improve this voltage, and this will improve after the support from this circuit. Okay, these all are the results which I am getting. This is the entrance side voltage and that is the exit side voltage of the connection point. My entrance and exit, I means if I put on the virtual wires option, you can see the connection will be visible in front of you. These are the in and outside of the integration point. Here I just measure the voltage. At the output side, initially the voltage is low, but after the integration, as you can see, the voltage improved. Now as you did earlier in the as you did previously in the previous exercise, you want to know what is the impact of this this filter circuit. So I just want to do one thing. I just remove one filter circuit connection here, and let's see what will happen to our DCs. Okay, now let's see. I just remove one and I just put it on. Here you can see rectified side DC, sorry, not rectified, receiving side DC, because I just removed the receiving side DC filter This is receiving point filter I removed, and you can see the impact here at the DC line. The impact also shown here. This is spike. Now just keep these two graphs in mind. This is slight increase due to again the harmonic distortion, and there is a very disturbing output we received at the receiving side of DC line, again due to the harmonic distortion. Let's, as you need to compare it again, you need to observe it. Okay na? If there is any question in between, please ask me. Now what I will do, I just connect them, and after connecting and before running I just show you again the graph, and then we will run and you can observe the difference. This is the graph when I just disconnected one of the harmonic circuit, filter circuit. Now you can see the spike which reach up to this 8 point is now reduced, and you can also observe the receiving DC side. I named it as per the convenience of mine. Okay, let's okay, now what we will do, we will make a complete transmission circuit at the secondary side, and then we will do some analysis on this DC line integration, and we will cover some transient in it also. We will make some events. Now it is your task. We have a 30 minutes. Please try to make it. You already make a 250 kV now, and this is the, as you know that this is bipolar. So I want you to make homopolar, as we made it, I think, in the second class. Now please try to make a homopolar. It is much easier, it is fast to make, and for the bipolar please try it at home, and if there is any issue please let me know. Yes, you can ask questions. The alpha and beta, the firing angles, you need to change through this controller circuit. Okay na? This controller circuit have, as I told you, with the help of this controller circuit you can alter your alpha and beta, or what you better say, these firing angles of the SCR, this bridge circuit, and you can observe the different effect. Leave this whatever you have this in your system. Try to observe that why these are in your system, why they are taking, if they are taking 10 degree or 20 degree, why it is so. Okay na? That is, I took 30 degree here. Okay na? I have a smooth everything. I have no disturbance in my system. Yes, these are the case study of our recent project, DC project, and we just change the values.